Welcome to MyProjectBazaar.com. Our project title is Efficient and Scalable Public Key Infrastructure for Wireless Sensor Networks. Abstract. It is important to make a wireless sensor network a secure environment because many applications such as military, medical and industrial sectors requires several kinds of security services such as confidentiality, authentication and integrity. The use of PKC alone is not enough for protecting a wireless sensor network. It is necessary to have a public infrastructure that can be able to establish a trusted identity among other things. It would be extremely useful to have a cryptographic primitive such as public key in order to create services such as digital signature cryptography. For achieving secure and efficient network, we propose our own energy efficient and scalable PKI for WSNs. Let us see the flow of our project. First, network formation is done. Our network is Hutchison formation. Then next we have to select the cluster head based upon the energy. The node which have highest energy is taken as cluster head, and we have to done the PKI operations. In PKI operations there are three types of operation is there. First one is certification issue and certification storage and certification revocation. These are all performed by cluster head node, that is H node. If the compromised node is entered, we have to blacklist that node and provide a secure transmission, else it analyze the process using four parameters, that is packet delivery ratio, throughput, energy and delay. Let us see the output of our project. Before running our project, we have to set the path for our NS all-in-one 2.34 package. In existing system, they use the old versions such as NS 2.28 or 31 or 29 or 30. So for that, we have to type gedit space delta symbol slash dot bashrc. One notepad window is opened. In that we have to replace this 2.29 as 2.34. And change this name version as 1.14. Then save that, close that, and in terminal window type cd space ns all-in-one 2.34, then cd space ns 2.34, then type make for configuring the file. So now make is performed. Then open a new terminal window and going to our code. So when we type on ns space main.tcl, it will works. So energy and the ECDSA parameter, that is our elliptical curve DSA parameter, is done. So two types of keys generated, that is private and public key, and the security process is done. So now our process is in 160 bit long prime. So type nam window. So this window is open. In that, open our process. the NAM window is open. NAM is nothing but network unlimited window. When we start this play forward button, it works. This is for simulation speed. We have to increase or decrease the speed. So this is for simulation end time. So our process is first region splitter depending upon the coordination value. Next cluster head is selected. Then this node is cluster head, so the transmission is done via this cluster heads, and this is for our security parameter. Parameter, that is our keys stored in distributed hash table. So in polynomial factor, we have to calculate this security parameters and store it in DHT, that is distributed hash table. So hashing store the values, and this is for 160-bit long prime EDCSA concept. And this is for energy, the node which have highest energy is taken as cluster head, so we have to calculate cluster head energy also. So the transmission is done via this cluster head node, that is H node. All other nodes are act as a L nodes. These round circles shown about the transmission range. So what is performed by the transmission? So acknowledgement is now performed, and RTS CTS message will be performed. So for graph generation, we have to type GNU plot space thr.plot. We have to compare the mean node speed versus average throughput per flow. So in existing system, their throughput is less than our proposed system. So throughput is nothing but number of successive packets sent at time. So we have to achieve more throughput than existing system.